Hello, everyone. My name is Rachel, and I'm joined by my colleague Kavitha, and we will be discussing powering the future, making AI work for us and the planet.
Wow.
All right, so we have a beautiful graphic of the United States. The darker blue states indicate a higher concentration of data centers. So if we are making a query on ChatGPT, for example, from Pittsburgh, most likely that query is using a data center in one of these higher concentration states. For example, you see California, Texas, Florida, they are higher concentration states. So as a result, we can expect that these states will have a higher demand in their energy usage.
All right, so I'm going to be discussing the hardware energy consumption breakdown at these data centers. And as you would expect, most of the energy being used is from the actual IT equipment itself. So think of your server rooms. How many of you have ever been near a server or in a server room, by a show of hands? Okay, so you all know those rooms get really, really hot. So we're going to need to cool down because essentially we're doing the hardware's crunching through all these numbers. So we're going to need to cool down these servers in order for them to function and exist. All right. So on the other side, so we have our software energy consumption breakdown. So as you would, actually not as you would expect, but for the development and the actual training of the AI doesn't consume most of the energy. It's actually the use of the AI. So the multiple times that I go on ChatGPT trying to find the best s'mores espresso martini recipe, it probably is not helping with that energy consumption.
All right, so let's try to conceptualize this with a basic 10-watt LED bulb, courtesy of Courtyard Marriott.
Yep.
So our basic Google search 4 years ago would use about 2 minutes of this light bulb. Now with ChatGPT, every time you type in a prompt, that's about 17 minutes of this light bulb. And then as you get into the larger language models like the AI-powered Google search we have now, that's upwards or close to an hour of the light bulb every time you search. So these are numbers from ChatGPT. From the EPRI, but about ChatGPT. So every day they receive about 1 billion prompts. That's about 2.9 million kilowatt hours per day.
All right, so what can you do? How can we be more efficient when we're using our AI tools? And I really like to think about back when I was younger in 6th grade, learning how to write a search engine prompt. And it's kind of the same thing. We are gonna have to learn how to speak and communicate with these AIs. And being able to do that is going to drastically lower our energy consumption. I put an example of a prompt from the AI Pro website, and I'll kind of walk through what all of these things mean. But one thing that you're always going to want to do is just put a role. So you're going to tell the AI, assume that you are this role. The next thing you're going to need to do is be able to tell it what to do. So what are you going to try to generate? What type of content you're going to generate, and what format I'm going to try to generate that specific content. Even more importantly, okay, what's the goal? What are you trying to accomplish with this content? And then last but not least, the audience of this content. What I'm going to give a lawyer is going to be very different than what I'm going to give a doctor in the terms of content.
So if you could reduce your prompts from 5 prompts to just 2 using that formula, that would save like close to an hour of running our light bulb. And this is specifically for ChatGPT. So here we have an anecdote from Amazon's sustainability report from last year. This is just some of the cool things they're doing to reduce their impact on the environment and the energy usage. So the one that I've highlighted is their increase in water efficiency. We talked about cooling down these data centers. So instead of using the water all the time, they're actually using ambient air, kind of like an evaporative cooler or swamp cooler. To cool down these servers, when the ambient air is too hot, they introduce the water, and they also have installed alarms to indicate when there is water leakage. And lastly, they treat the water before it outfalls into the watershed so it can be used by downstream users.
Thank you all.
Thank you.